Ah, what does that mean? It's unhappy for some reason. Unable to open audio stream. Okay, we'll try another recording. I guess if that doesn't work, maybe I should reboot or something. Okay. Well, anyway, obviously, I do plan to post the sample, the starting point. So the stream is, if I want to overload operator for any stream, yes.
Never mind. That's
Yeah.
Speaker's off. Never mind.
Yeah.
I'm sticking the microphone.
Yeah, no, the microphone is on. So if I say output stream, actually it did save, right? It did save something. Okay, never mind. We'll find out what's going on. So here, to display our string, it's kind of easy because string has a str function which returns a string version, and the string really knows how to display it. So this is what we do, just do something like that. A very simple implementation for the output stream. Okay, let me make sure that this works. So we'll already have places where we use string, but now it should be possible to simply use our substrings in the stream output. That should work. With all this previous testing, let's just sort of like keep our stuff separate, and over here I can say okay, so that I can see that it works. So build. Okay, so our string contains those add characters, so this worked, right? So now we're armed with this first test with using the operator, and so it's fine. So our substring class now can be easily inserted into the output string. Of course, the opposite should be possible as well if we overload the input operator, but let's focus on other operators first. In general, it never makes sense to start working on overloading operators unless you already have a fully functioning class, and we do, right? So in our case, we have all these functions that already do something useful, and we can rely on their presence to implement the operators. Typically, there should be a well-named private or public function inside of the class that implements what the operator does. So let's demonstrate that. By the way, in our header file, we just copied and pasted the declarations of our overloaded operators, whereas in the C++ file, if you recall, before we ended previous week, I actually copied and pasted them all and gave them some sort of a body, in many cases just stub out like this, so that I can compile, but now I have all these operators. Some of them already have useful comments. So let's see. Now in this situation, I want to compare two substrings together, like compare them. So what I can do, so this is the case of overloading this operator, and this is the situation where I compare two substrings, right? So I want this to work. Well, again, you can come up with different solutions. What I would do is simply say, does one string compare to another substring? And I can do all this because I already have strings which themselves overload equality comparison operator, and it's supposed to work. So if I can take substring and convert it to string, as you recall, this function of the substring returns an equivalent string. So I can simply compare strings, and this should work, right? If I can convert a substring to it may be inefficient in a way, but I really don't care about the efficiency. I want to demonstrate the quickest way to make sure that our operator equality test works for the substrings. So efficiency can be improved. We could write something else, some other version of it. For example, as far as I can remember, if we go to C++ plus.com, which is a popular resource to find information, and if we go to string documentation, and if we look at the functions that are available here, operations, find, here's the compare. There's a whole family of compare functions that we can use as well. So we could employ our substring offsets and use this family of compare functions which compare essentially parts of string, and that's what we have. And so we could probably use this family of functions, find suitable one to work with, that we could that we could use to implement our test. So let's see, compare string to another string, compare starting from position and length and another string, and here's a promising one. Compare position 1, the length, and another string with position and sublength. We could probably use this version. So we can do something like this to demonstrate it here. Perhaps, if we consider this not to be entirely efficient, we could use this version. So it's now time to look at the header file side by side, and we realize that inside our substring we have a reference that refers to the mothership, the string class, the instance of the string class, right? So we have that. So we can use one dot mster, right? Compare. Now compare where? Compare starting from position m begin, right? Compare starting from position m begin. And let me rearrange this a little bit. The length will be, we'll already have the size, right? The size. Let's see, we have size implemented here. Quick check. Yes, size is already implemented, so I can use size. Substring 1 dot size is the size of the substring. Another string supposed to be given to us by another substring. So another substring also contains a string, which is mstr, a reference to the string. And there we can specify its subposition as, let me make sure that I structure everything correctly. One mbegin, one size, another string, another mbegin, and its length, another dot length. I'm sorry, size. We use size. So it is possible to specify it, but in order to make this work, if we were not satisfied by this version, we could try to rely on compare member function of the string, right? Because we have substring, which contains reference to string, which can be used with compare method, which takes these parameters. Where do you start? What is the length of this portion? What is another string to compare to? Where to start there, and how big the portion is. Let's save this as well.